Hello, this is Rashad from Robotic Automata, and we will be solving a little prime finding kind of program in Java. So let's go ahead and specify that a little bit more clearly. So I'll go ahead and open up a terminal for y'all and just zoom in. So let us just make a little goals for today. Solve primes in Java. So what do I mean by solve primes? So we will essentially want a list, say something like 1, well maybe not 1, we don't want to start below 2, so let's say 2, 3, 7 or 8, fine, 7, well it can have multiple, it doesn't really matter, 10, and it will return back to us just the primes. So this will be our input, this will be our output. So why bother? Just a simple programming exercise. If you're interested in learning about programming, also great interview practice. This is the kind of stuff that you might get asked in an interview. So not just your ability to solve the problem, but how would you go about solving it, right? Like I'm not just gonna show you a solution and then explain it, but we're gonna do it live. I'm hoping, for both beginners and advanced, you can pick something up from this little instructional. If you're more advanced, hopefully the way I go about it will be quite illuminating. So we will specifically be doing things like also setting up on Git, setting up Maven, which is really good for test driven development. We will also be using TestNG in this particular case. Maybe in another situation video we can talk about TestNG versus JUnit, but for the purpose of future videos beyond this, what's next, I would like to do API and UI test automation, and I think we can just use JUnit 4 and 5 respectively for those. So in that case you'll get an opportunity to see various testing frameworks in Java. So now let's go back to trying to solve this problem. So what do we need to do to even begin to solve something like this? We need to pick a programming language. So in this case, let's just say we're going to pick Java, assuming we're going to do it in programming. Oops. I think I was going to quit on accident. So how do we set up a Java framework? How do we set up a Java framework? And I'll put framework in quotes. And I'll explain why. So we could just create a plain .java file, Java compile it, then run. But I think it would be a little better to set up so these are our options, I guess. Option 2, we can set up a traditional Java framework using something like Maven to get us dependencies we might want. And in our case, we're going to use TestNG as a dependency. What's nice is it will be easier. So one of the pros of going about it this way, easier to get dependencies later if we need any. Sets up the structure of our framework, meaning we will have a source/main/java where we can implement our solution. We will have a source/test/java where we can, write tests to to verify our solution is working. And this also allows us to do test driven development. So let's go about it the second way. So how do we make a Maven project? So I'm going to want to just get a simple archetype. So let's just go to Chromium. And, we can do it from the command line or we can do it from Eclipse. I think I will choose to do it from Eclipse, but I want to verify what is the name of that archetype. So I think I can just look up Maven simple archetype. And actually we can just do it from the terminal. So this will essentially specify, let me zoom in for y'all so you can see. So we're going to do Maven Archetype generate from this website. So org apache Maven Archetypes. The archetype is Maven Archetype simple and the version is 1.4. I'm curious if this has a more up-to-date version. That is, I wonder if this website is not being maintained, documentation. Nope. So it is 1.4. Great. So let's just go back there and get that. So now we will go ahead and open up a new terminal window, and we can just paste that in. And assuming you have Maven installed and all that stuff on your local machine, it should create a project for you. So it's going to ask stuff like, what do we want our group ID to be? So I'll just call that robotic automata. Artifact ID, I will call that Java practice or programming challenges. How about that? I think I have to do a undo somehow. Let me just try that again. I don't want it to give me the wrong name. So group ID, robotic automata. And let's call that Java programming challenges. Yep, that is sufficient. This is all sufficient for me. Great. So now we should have Java programming challenges. So let's go back to our goals. And yeah, how do we do that? We can just go ahead and paste that in there. So now let's set that up in Git. And the main reason why I would like to use Git, let's say why bother? Why bother? Well, one, I'd like to publish this online for y'all to see, which is also useful for you to know how to publish online. Two, if I mess something up by committing along the way, I can revert to a previous essentially snapshot, or let's say commit, a previous commit. So what that means is, let's say I managed to write some functionality and it's working, and I commit that, then I do some new stuff and it's not going the way that I hoped it would. I have the option to revert back, and that is extremely helpful from a development perspective. So even if you do not intend to publish online, it is still so useful to get it set up in Git. So let's go to Java programming challenges, and let's do let's see, I would like this to be online. No. So I think in the previous video we showed how to set it up online. This time I will just set this up locally. Git init, git status. So it'll say we have a POM and we have a source. Let me just do a little tree to verify what we have. So we have a POM.xml, source, main, Java robotic automata, site. Yep, everything looks great to me. I don't think I need that site, but it's fine. So let's do git add dot. And then let's go ahead and do git status again. Verify what we have. Yep, that looks great to me. Just 4 files. Git commit. Well, normally it would be git commit -m, but I have a little shortcut. Initial commit. Sure. And there's nothing to push right now. I did not set it up on the UI, but let's go ahead and well, actually, yeah. Let's go ahead and check out a new branch. Oops. Great. And now let's open this up in Eclipse. So why bother using Eclipse? So let's head over to Eclipse. Why? Well, you know, there's a million ways to work on this project. Maybe we can use different IDEs, but why use an IDE in general? Hopefully we can show some of the value of using an IDE. One of the main values I would like is code completions. Oops. Ease of running individual tests. I would like generating non-implemented methods / classes, but I've been having a hard time with Eclipse doing that for me. Maybe with IntelliJ it would be a little bit easier, but IntelliJ is not working on my computer right now because I did a little bit too much playing around with plugins and things of that nature. And now if we compare that to, say, doing things in the terminal, we'll have to manually compile and run tests, make sure we have Maven Surefire plugin set up. There's also a very valid way of doing things, but let's not go in that direction this particular video. But perhaps next videos with UI and API test automation, instead of running the tests in Eclipse, let us use, you know, Maven clean test or verify, you know, something along those lines in the command line. So it can be done in the command line for sure. So let us go to Eclipse. Okay, so we had a little cut because opening up Eclipse takes a moment on my computer, but now Eclipse is opened up. So now that I have Eclipse opened up, I will do file. Let's see, import existing Maven projects. Now let's go ahead and browse for the project we are looking for. I want to go home and then robotic automata, Java programming challenges, and yes, we're essentially just looking for a POM.xml. Great. So I want to look at their test /Java, and if I remember correctly, this little archetype is a little bit out of date. I think they're using a very old version of JUnit. So I will likely be getting rid of this test and putting in a TestNG version. So let's see, what version of JUnit do we have? And let me get rid of, where's my drag option? Let's just use my down, minimize. was looking for the drag to make that smaller, but I didn't see it. At least in a fast enough time frame that I care. So we're using JUnit 3. I would like to switch this to TestNG. So TestNG, Maven Central. I will get the most recent version. And let me remember to zoom in for y'all. Oops. So we can just go ahead and replace our JUnit with TestNG. And let me just format that. Oops. Press the wrong hotkey. Let's go ahead and look at our Eclipse format is Control-Shift-F. Okay. Thank you. So now our pawn has been edited. So the next thing we would like to do is do a little refresh. And I suspect this will start failing for us because this was relying on JUnit 3.81, I believe. So extends test case will no longer exist. So let us get rid of, let's see what are we even importing in the first place. So all of this will no longer exist. Oops, did not highlight what I wanted to. We will not be extending test case. So let us get rid of essentially everything besides one test case. Sure, we will do a test app, but the format will be a little bit different. I personally would prefer not to do static inputs, so let's do assert true. And let's go ahead and get at test. So I'm choosing to do code completion on at test, mostly so that I can get auto import as it happens. Great. And I do have TestNG plugin on Eclipse, so I can just click run. I'm hoping to just see it says test pass. 1 test run, 0 failures. And I'm wondering if it says pass somewhere. If not, that is sufficient. But let's just verify that, this is working. So I'll go ahead and put a false there, and I should see a fail. Great. Oops. Yeah, I was not reading it. It was saying total test run is 1, pass 1. For some reason, I read this all together. But anyways, so now we can go ahead and commit that, and that's one of such a huge value of Git, which is now I can say Git status, and it says we got a bunch of stuff that I do not care about, and also maybe this is a little bit too big. So we modified our POM and we modified our app test. We do not care about a class path, project, or test output. So let's go ahead and add that to Git. And it looks like Eclipse also generated for us a little Git ignore. So .class path, we do not want to ignore our .git ignore. .project, settings, test output, great. So now let's go ahead and do git status again. So now we want to add our git ignore, and before we add our POM and apptest.java, I think it's a good practice to just do a git diff to see what it is that we changed. So we did do a few formatting changes. Maybe if you were working with other individuals, you would choose not to edit lines that you did not touch, but for our intents and purposes, that is sufficient to leave things as they are. But for the most part, we went and deleted JUnit, we got TestNG, and that's pretty much it besides formatting. Now we're going to look at app test. We deleted a lot of stuff, but we did add TestNG assert, and we got assert true. Great. So now we can say something like git status again, git add dot, which should just add these 3 files, but we can check again to verify. Great. And then git commit -m add TestNG support. So already I would say that is a huge win for Git, because now I know that TestNG is working correctly, and you know, if I do something wrong as I proceed in implementing our prime solution, I can always come back to this state or this commit where at least I know TestNG is working. So, oops, how do we proceed with our prime problem? And if you forgot, our prime problem is this. We're going to get some list of numbers and we want to strip the non-primes. So first, let us begin with TDD, Test Driven Development. Essentially, we're going to specify our requirements into a test case and then figure out how we can begin implementing that test case. So we would like to do something like copy app test, and now we're going to create a test for, let's say, prime factory. Let's say prime factory will solve our little prime programming question. Now let's go over to prime factory. Let's make this smaller. A little bit bigger for y'all to see. So now I believe I will want some sort of method like strip non-primes, and then we're going to do a test for that method. So we want something like a list of integer, and I'm hoping it's saying we need to import. Great. Maybe I gotta check if my what my auto import settings are for Eclipse. So list of integer, let's call these primes, equals, let's say, a new array list, but let's just use control space so that I can get auto completion going. And in addition to that, let's do arrays Maybe that's the wrong one. Oops. As list, perfect. So let's say our primes will be something like 2, 3, 7, 11, sure. Just a few primes. And we will want to do something like assert equals so in our actual value we want primes, and then in our expected value we will want something like prime factory dot strip non-primes of primes. Let's go ahead and put this on a new line. Great. Now it's complaining because it says, hey, you never implemented a prime factory class, so please recommend to me to implement that class. Create constant prime factory, create class is what I would prefer. But where is this located? Project will take automata, great. No, not great. We want this to be in our main. And yes, that should be what we need. And then we come back here and hopefully now it will recommend us to implement this little method. Great. So we can just return a list of type integer. And what does this do? So this is where we can specify a Java doc to clarify for other individuals what this little method does. So it takes a list of numbers and strips the non-primes. Does not alter the given list. So return primes, and this will essentially be new list with only the primes present. Oops, this is supposed to be our input. I got confused because this had primes here. We'll just call this input. Input, that will be a list of numbers. Great. So let's continue with our testing. Because we did it for primes, I would also like to do a test for non-primes. So let's say non-primes. We could even do multiple tests. I think it is worthwhile to do multiple tests. So let's call this strip non-primes positive test. And then let's do a negative test. Oops. The main benefit of doing separate tests will be maybe we're able to find primes correctly but not non-primes, as opposed to it just failing and then it's stopping and not doing the second assertion. So let's call this non-primes. Oops. Let's call this negative test. Let's go ahead and put in 4, 10, 12, 33. Great. Now we want our list expected. To equal new list. And it should be empty. Might need to give a specific instance. Okay, and that is just because list, I believe, is the interface. So now we're essentially saying, hey, we're going to give you this list of non-primes. What you should return back to us should be nothing, just a plain list. You shouldn't have added anything to it. Great. Now, I think I'm missing a brace. And now we should be able to run this class, so we can run prime factory test, and it should fail for both tests because our method does not do that. Our strip non-primes. So 2 tests run, 2 failures. Great. So now we can go back to our terminal and go to GitHub and say, hey, Git status, where are we so far? We did some changes to prime factory and prime factory test. Let's verify what they are. Oh no, we can't see a git diff because these are completely new and added. Anyways, we can go ahead and git add those. We have 2 new files. We can do git commit -m. Oops. And I would like to say something like, what is this? A method called stripNonPrimes. Add stripNonPrimes tests. Essentially. Great. So let's go ahead and figure out how would we implement this stripNonPrimes feature. So let's go to prime factory. Returning null is not what we'd like to do. We want to say something like, we're receiving a list of inputs, so we're going to have to iterate over these inputs and, iterate over input the ones that are prime, add to a result to return. So how do we go about doing that? So we can say something like list of type integer, result equals new array list type integer. Great. For int element in input, if is prime of element result dot add element. Return result. Great. Now it's not so happy with us because it's saying, hey, you never implemented is prime. But that's essentially what we want to do. We want to check for each element in this little list that we're getting if it is prime or not. So let's go ahead and implement that. So let's make this protected. You can go ahead and make this protected as well. just want it to be visible to our tests. And what is this isPrime supposed to even do? So we want to say something like, verifies if input is prime or not. Let's call this input at param input to be checked for prime status. Turn true if prime, false otherwise. So great. So now let's go ahead and do a little testing for this. So we can say something like at test public void is prime test. And we can do something like assert true, assert true, and we want to assert true that prime factory of is prime of 2, and that is indeed true. And let's just do that for a couple tests. We could make 2 separate test cases or multiple test cases just like earlier, but I think, just a single one is sufficient. So let's say 7. And let's go ahead and do that for maybe something that are not prime, like 10. And this time let's do an assert of false. Well, we're going to space that again. Let's do 12 and false. So we're just going to say, hey, prime factory of is prime of 2 should return true. Same thing for 7, but for 10 and 12 they should return false. And these tests cannot work until is prime test is working. So we can do something like depends on methods is prime test. Great. So essentially what we're saying is, hey, we want to test these 2 tests, but we don't want these tests to run until this test is running and passing. So we could go ahead here and click run and verify if this all fails, as it should fail. But even better, we can go up here and click run all, but it should not even run this stuff until that's running, so it'll effectively do the same thing. So we see 2 tests were skipped, 1 failed, and 3 tests were run. So great, that's what we hope to see. So now let us check what we have so far. We modified prime factory and prime factory test. So let's see what are those modifications. In prime factory we got an array list. We made this protected. We don't want to commit our comments, so we can get rid of that. So that's one reason to check before you add or commit anything. And yep, things are looking good to me. Oh, I forgot to keep checking for our tests. We added our dependencies on the first 2 tests, and then we have a couple more tests. Great. So let us go back here and remove our comments. Great. Now let's go ahead and do git add dot get status GCM add tests, add is prime test, essentially. Great. So once again, we just create a little commit to save what we have so far. So as we begin to implement the is prime test, if things are not working as we like, we can always come back to this state of affairs. So how do we go about implementing is prime test? You essentially want to, I think, there's many ways to go about it. One thing I would like to do is let's go to our whiteboarding. How to implement is prime test, or just is prime. I would like a list of, essentially primes, like kind of like 2, 3, 5, and we need to kind of build this list. I don't want to have to manually type out primes, because I'm gonna run out like 11, 13, 17, 19. Like, what if we get a really big number? I want the computer to generate that list for me. But I would also like to know the non-primes as well, because what if we get something like 4? What if we get something like 4? I want it to say that is not prime. So perhaps not a list of primes, but something like 2 true, 3 true, 4 false, 5 true, 6 false, and it will continue on as follows. So perhaps we can make a tuple or table or map, something like that. But given that the items on the left are all increasing and it's just by position, I think we can do something like a list of booleans, and we can say something like just based off the position. Let's say null for 0, because if you know in software engineering, computer science, a lot of times the index, the first element starts at 0. So null, true for 2, true for 3, false for 4. And what I mean by that is, this is 0 position. This is position 1. This is position 2. This is position 3. So essentially just what index are we on, and based off that index I want to store the value of whether or not this is true or false. So I think what I will do to implement that is something like list of type boolean equals new array list. Oops, I did not give the name. Let's call this prime status. New array list of type boolean. Let's go ahead and put inside of here arrays.as list. And it can be no true. So 0 is null, 1 is no, and 2 is true. Great. So we would like to essentially do something like, hey, if we get a number, let's say 2, in our case we're defined all the way up to 4, let's call the list of booleans prime status. Then we'll say, hey, just return prime status at 2, which is true. How about 4? Okay. Return prime status at 4, which is false. Now, how about 5? Well, we don't have 5. We don't have 5. Can we increment and build up prime status? So how would we go about implementing something like that? So I guess we want to say something like, is our input the size of prime status? So this list has what? 4, 1, 0, 1, 2, 3, 4. This is actually 5. Because we're starting at 0. So if we get the number 5, the number 5 is equal to the size of prime. That's not good. So essentially we want to see, is it contained in the index without an index out of bounds exception. So something like perhaps while primes.size is less than or equal to input prime status. Do I need to make this static, I believe? So while prime status dot size is less than or equal to input, so essentially in our case, for example, prime status, the size of it is 3. So let's say we get the number 2. 2 is contained, okay. 2 is, less than primes.size. Prime status size is 3. 2 is less than that, so we will not go into this loop. So in that situation, we want to say something like result equals prime status dot get at input. So we want our result to be of type boolean. I don't really think we need to specify that in advance. We can just return it. Let's get rid of this comment. Prime status builder. So what are we doing here? We are essentially saying something like, hey, we want to grow our list of prime status to be at the size of whatever it is that we're receiving. If what we're receiving is this order is throwing me off. Let me write it in the other direction. I think I might have been mistaken. Actually, I think I got it off. If input is less than or equal to prime status, dot size. So let's just do some pseudocode. So let's say we get 2 coming in. 2 is less than 3. And we go into here. No, that's not accurate. We don't want to go into here in that case. Okay. So So is 2 greater than or equal to 3? It is not. So we will go here. Great. What if we get something like 5? Well, 5 is greater than or equal to prime status size. So let's go ahead and do prime status builder. Great. So let us implement prime status builder. So essentially we're gonna check we're going to increase the size of prime status by 1. So we want to say what is the size of prime status, or what is the number that we're checking. So something like int number to check equals prime status dot size. So for example, let's say our prime status size is right now 3. So we're going to check, because 0, 1, 2, the size of this will be 3. And we want to say, that let's just assume that it is true. So boolean is prime. We want something different because I don't want to reuse something that is prime. Well, we won't be touching that, so we can use this prime boolean. Boolean is prime equals true. So let us assume that the number to check is indeed true. So what we want to do is a loop. Loops through each element in prime status. If it is divisible by something in there, perhaps not element but index, up to number to check. So loops through each index up to number to check. If it is divisible by that index, then set is prime to false. Exit this loop. So I think something like a for loop can work. So for int I equals 2, because that is our starting index, meaning we're not going to start at 0 or 1, those don't count. 2 is where we would begin. We want to do something like, what is our checks? If it is divisible by that index, that's going to be in here. So what is the index that we're going up to? So we want something like I is less than number to check. I plus plus. So we're going to start at 2. We're going to keep going up to number to check, and we're going to keep incrementing I. If 0 equals I percent, oops, we're going to number to check. So what we're essentially saying is the number to check, let's say it is 3. If 3% high, in this case 2, that's not going to work. But let's say it was, something that is not prime, like 6, and we're all the way at index 6. It's going to say, oh, that is divisible, divided by 3. Oh, 6 is divisible by 3. Set is prime to false. And then we want to exit out of this loop. So we want to do something like is prime. So for example, if we still have the assumption that is prime is indeed true, then continue with this loop, and also as long as we are less than number to check, keep going. However, if it is divisible by the index that we're on, then go ahead and make is prime false, and that should take us out of this loop, because that is prime will become false. And then we can go ahead and return is prime. Oops, we're not returning this prime. We are doing prime status dot add is prime. Great. And I believe that is what we want to get our test passing. Now fingers crossed things work, and if they don't work, so let's just go ahead and take our next steps. Let's see if our tests pass. If yes, close shop. Otherwise, read the code line by line, consider using print statements or a debugger. But if the moment of truth is nice for me, it'll make the video a lot easier for me to just have everything working. So let's see. Great, so the tests pass. So what is some closing of shop? Can we do better? Well, first of all, there is quite a bit of duplicate effort because we are also dividing by things that we don't need to be. What I mean by that is, let's say the size of this was 10. We have 10 elements in here. And, let's say we got a prime like 17. Now 17 will be divided by not only 3, but even 6, which is unnecessary. We don't need to divide by false elements. So instead we could do something different. Like, what number are we on? Up to, instead of primes.size. And, only store the primes. So in this case, divide by 2, 3, 5, ... but also track that we're currently on, let's say 6. That's where our pointer is. We have not verified if 7 is prime or not. That could be a little bit more optimized, as an example. But maybe there's even more optimal ways of doing things. But for now, this is sufficient. The tests are passing, and I will go ahead and put this on GitHub. What's next for you? If you choose to subscribe, hope to do some API testing, UI testing, and in the comments there will be link to GitHub and a blog tutorial hopefully soon. These are the kind of things you may be asked in an interview. Oops. And I did write a free interview guideline you can download. Otherwise, I hope you enjoyed and learned something. If you have any tips, I'd love to hear them. Thank you.